So let's look at questions 13 through 15. This one should be a fairly short video. So question 13, it's been a little while since we've done any constructions. So if we're looking for a segment bisector from A to B, which is equivalent to the construction if we said find the perpendicular bisector, or if we said to find the midpoint, all of those things are the same. So what we usually tell students to do on this is take your compass and open it up a little bit more than halfway to A to B. And again, it could be a lot more or a little bit more, but it does need to be more than halfway, and that's important. So I picked a value like this that is more than halfway, and I'm going to draw an arc from A, and then I'm going to move my compass over here without changing the opening of my compass to part B. And I'm going to make the same exact arc. And as such, I call this usually the fish. But if I were to play connect the dots between these two values like that, what I have done is I've created this bisector that AM is exactly the same as MB. So this bisected, this thing cut that segment in half. But it turns out it also made this to be perpendicular. So that's a perpendicular bisector. And that point is the midpoint. So if I said construct the midpoint, the angle, the segment bisector, or the perpendicular bisector, all of those would be exactly the same construction. Now, this one has a very, very similar idea in that you open it up to some random value that feels comfortable to you. And usually with a compass, if you open it up too wide, it's hard to make a construction, but if you make it too small, it's hard. So I try to be like Goldilocks and the Three Bears and just make something kind of in the middle. So I'm going to make an arc that goes like this, and I'm not really paying any attention to J or G. They're really irrelevant to the story. They created the angle, but I want to bisect the angle. So I did this, and I created these two new values. I'm just going to call them X and Y for a second because that just helps. Now what I want to do is really the same thing I did over here, and I'm going to open up to X, and I'm going to draw an arc out here in the middle from X. And I'm going to do the same arc over here from Y. And I'm going to find out where they cross. Now, the difference here is that I didn't have to keep going and find out where they crossed twice, because as it turns out, I don't need them to cross twice. I needed 2 points over here, top and bottom, but right here, I just needed one extra because I already know I want to connect that spot up with that spot. And so we actually have our value that we need, and I'm looking for my ruler. I seem to have set it down somewhere. So, oh well, I guess I'll just use the edge of my trusty stapler right here, and there we go. We would have our angle bisector of that thing. All right, now I found my ruler. It was just underneath my paper. Okay, and then our proof. So in my given statement is that angle CAD, that's this guy right here, is the same as the measure of angle EAF, and that's given over here. Now, ultimately, if we read what we're looking for, I would like to go, I don't want to talk about CAD, I want CAE. So in order to make CAD into CAE, I need to make this angle larger by adding DAE to both sides. And that's just called the addition property of equality. A property of equality is that you can add the same thing to both sides of an equation. Now, the interesting thing is if you did CAD plus DAE, if you look at how that works, CAD plus DAE becomes CAE. And equivalently, DAE added to EAF would become this angle right here. And we call that the angle addition postulate. That's something we cannot prove that it's true that the small angle plus the larger angle, it becomes that whole angle or something like that, or the bottom and the top adds up to the whole. We can't really prove it, but it's obviously true. In the same way that the left side of a line plus the right side of a line segment would be equal to the whole line segment. That's just, they call it a postulate. You can't prove it's true, but we know it's true. But if you put it all together, if I know that this side is the same as this side, then what I could do is I could substitute CAE for all of this stuff that I have written right here. And I could take all of this stuff that is sitting right here and I could substitute angle DAF. And that is exactly what I wanted to show, is by substitution that those two angles were the same. And I believe that that finishes up our 6-week review. And so I think we'll stop it right there. I'll see you back in class. Bye-bye.